This is problem 11 from chapter 10. A powder diet is tested on 49 people, liquid tested on 36. Of interest is whether the liquid diet yields a higher mean weight loss than the powder diet. The powder diet group had a mean of 42 pounds, standard deviation of 12. The liquid diet group had a mean weight loss of 45 and a standard deviation of 12. So it looks like we're going to have to deal with two samples here. And so let's make a chart for two samples. We are looking at the powder diet and the liquid diet. So let's label these powder and liquid. And just for simplicity's sake and also for a calculator, it would be good if we just label these 1 and 2. So powder came first. I'm going to label that 1 and liquid label that 2. So each of these would have a mean given to us. The mean for the powder diet had a mean weight loss of 42 pounds. So let's call that x1 bar, the mean for our first sample, and that's 42 pounds. Standard deviation for that same group is 12. So the standard deviation, and remember this is for the sample, for the first sample, the powder diet sample, and that's 12. And for liquid diet people, the mean weight loss was 45, so let's call that x2 bar is 45. Our standard deviation for the second sample is 14. Now the other important piece of information are the ends. So for our powder diet people, there's 49 of them, and for our liquid diet people, there's 36. Of interest is whether the liquid diet yields a higher mean than the powder diet. So let's write that out. Liquid diet has a higher mean than the powder. So we're comparing means is what we're doing here. So in comparing the means, we can have the mean for the liquid diet, let's call it L, is higher than the mean for the powder diet. Now we have a little issue here in that the powder was labeled as 1 and liquid was labeled as 2. So if we were going to label this with mu sub 1 and mu sub 2, mu sub 2 is going to be up there first. So just to keep things nice for our calculator, let's switch this around and let's label mu sub 1. So this sign has to be switched also. Is going to be less than mu sub 2. So this is going to end up being our claim. Okay. If we put it all together now, let me switch pens here. As a hypothesis test, we need a null hypothesis and an alternative hypothesis. And this claim here does not contain a condition of equality, so this will automatically go to our alternative hypothesis. There's no equal sign here, it's a strictly less than symbol. Which means our null hypothesis, now there's two ways to write our null hypothesis. One way to write our null hypothesis is the exact opposite of this, which now contains a condition of equality, or another way to write the null hypothesis is to write it with an equal sign. So either of those would work for a null hypothesis. So we got the null hypothesis and alternative hypothesis. We have all our statistics needed to run this, and so we're going to go to our calculator and note that we are doing a 2 sample. Now this is a test. The question is whether it's a Z or T, and we make that distinction by identifying our sigmas, population standard deviation. Now we have two standard deviations here, but these standard deviations are for those 49 and 36 people, our sample. So here we don't have our sigma, and so since it's not known, we're going to go for a t-test. Alright, let's go to our calculators. Let's go to stats and right arrow to test. Now the 2-samp t-test is the fourth one, so you can scroll down 4 or you can just hit the number 4. We have statistics given here, and so we'll stick with statistics. Our x1 bar, labeled appropriately now because we set it up that way, is going to be 42. Our standard deviation for our first sample is 12. Our n, sample size, is 49 for the first sample. Now we go to our second sample. That has a mean of 45, a standard deviation of 14, and a sample size of 36. Arrow down means there's more information down there. And we come to this choice of inequalities. And if you can remember, this is always a choice for our alternative hypothesis. What is our alternative hypothesis? Our alternative hypothesis is a not equal to symbol. So back to our calculator, we'll select the not equal to symbol by right arrowing to it. Another choice here for us is pooled. Now in all the problems that we're going to do for this class, we're always going to select pooled no. We pool the standard deviations is what we call it. If we have enough information about the standard deviations and we think the standard deviations are going to be relatively significantly the same. We don't know that, and chances are when you're doing this in a real life situation you're not going to know that, so we'll just assume pooled no, and then we'll press enter and arrow down. So now it's just to calculate. So if we scroll down and see the other pieces of information, you'll see the other pieces of information here are generally from our statistics, so we don't need to worry about that. Although it's always a good thing to do, when you see an arrow up or down, you can scroll to see what other pieces of information are given to you. But for us, we only need to take note of our test statistic and our p-value. So our test statistic in this case is a t-test statistic. That's the distribution that we're using. Negative 1.036. It doesn't look like we're very far away from 0. Usually when you're about 2 standard deviations away, like 1.96 or 2 point something, then you're far enough away to say that there's something going on. But here it doesn't look like it. Our p-value is, I'd prefer that you call it a PV, although the calculator calls it a P. That's equal to 0.1518. Let's call it 19. So clearly our p-value is bigger than any alpha that we might have chosen. Had we chosen our standard 0.05 or even 0.1, our p-value is bigger than that. So because of that piece of information, we're going to fail to reject the null hypothesis. Now remember that this is a test to test the null hypothesis. Now independently, your claim may be the null hypothesis or may not be the null hypothesis. Like in our case, it is not the null hypothesis. So if we were not able to reject the null hypothesis, we can't really support the claim. So based on our test, the sample data, and this is an important conclusion, we always want to write our conclusions in non-technical terms. we can say that the sample data does not support our claim that, and then we should mention the claim in words, the liquid diet has a higher mean than the powder diet. Has a higher mean weight loss. We should look at it words. Mean weight loss than the powder diet. So regardless of how we set this problem up or how this problem was stated, we took it into the math world by identifying variables and labeling the variables appropriately. And most importantly, we got our null and alternative hypothesis set up. The whole test was a test to reject or to fail to reject the null hypothesis. And in failing to reject the null hypothesis, we were not able to support the opposite of the null hypothesis, which is the alternative hypothesis, which happens to be our claim. So this would be a good set of wording to explain our results in non-technical terms. All right, good luck with your homework.